Section 3-4, Addition and Subtraction Algorithms, Mental Computation, and Estimation. We're going to start by looking at how we model addition and subtraction, and we're going to use those models to help develop algorithms. Algorithms are processes that we use to perform operations. So the standard algorithm for addition and the standard algorithm of subtraction, those are two algorithms that you're probably familiar with. So let's go ahead and get started. Here we're looking at an addition problem, 186 plus 127, and it's being modeled using base 10 blocks. And to model our addition, we're noticing that we're grouping like figures. So when we add the two numbers together, we look for things that we can group together and combine to make fewer pieces. The top group of blocks is the 186 represented using blocks. The bottom is 127. And to add, all we're going to do is mush all of these together and then regroup so that we can use the fewest number of pieces to represent our outcome. Looking at the units blocks, we can see in this black circle that there's exactly 10 units, and we know that 10 units can be regrouped so that we can make a long. So out of the 6 ones from 186 and the 7 ones from 127, when we combine them, we have 13 ones. And those 13 ones can be regrouped. We can write that as 1 10 or 1 long and 3 ones. Then we move on to the tens. In our tens, we have 1 10 from our regrouping, 8 tens from the number 186, and 2 tens from the number 127. Adding together all of those gives us 11 longs. But 11 longs can be represented as 100 and 110. So I've circled all of the longs that I'm going to regroup into one flat. And then we can see that we have 3 flats, 1 long, and 3 units. This is modeling addition using blocks. And although it takes a long time and it's cumbersome to draw if you don't actually have physical blocks in your hand to play with, this is a great way to introduce addition of triple-digit numbers to children who've never done it before, because they understand this concept of trading and exchanging, grouping and trading and exchanging, and then they can look at the answer on the table with the number of blocks that they have left. Now let's talk about some algorithms that we can use. The first one we're going to look at is the expanded algorithm. In the expanded algorithm, we're going to add very similar to how you would in a standard algorithm, but there's going to be some small differences, so let's walk through it slowly. In the expanded algorithm, I'm going to start by looking at the digits in the ones place. So I'm looking at the 4 and the 3. We know 4 plus 3 is 7, and we know that fact from previous sections. And then next, I'm going to look at the numbers in the tens place. That's 1 and 2. But we're really not adding 1 and 2. We're actually adding 10 and 20. Now, in the ones place, we were adding the literal numbers 4 and 3. But when we look at the tens place, we're actually adding the numbers 10 and 20. When we add 10 and 20, we get 30. Now, this is different than what you've seen before, and it helps with explaining that a 1 and a 2 are not the same thing as a 1 and a 2 in the units column. When I add the 1 and the 2 in the tens column, it needs to fall directly under the tens place, and it will if we write it as 30. So 10 plus 20 gives us 30, and then we add that together to be 37. So we're really taking this 2 steps at a time. If we look at the standard algorithm, it's very natural for most of us because we've done it so much, but we look at the ones place, 4 plus 3 is 7. Look at the tens place, 1 plus 2 is 3, 37. We're not really showing our work here. So for someone who's seeing this algorithm for the first time, a lot of it is conceptual, it's in our minds, but none of it's written down to revisit later. The standard algorithm is great because it's quick and efficient. It doesn't take a lot of writing, it doesn't take a lot of space. The expanded algorithm is not quicker, it's not more efficient. In fact, it takes more writing and more space. But the benefit of expanding your addition like this is that you're actually demonstrating that you understand what the 1 and the 2 represent in the tens column. Let me show you an example where regrouping is required. For example, 37 plus 28. If I were to do this using the expanded algorithm, I would look at my ones place first. So that would be 7 plus 8. And 7 plus 8 is 15. So I'm just going to write 15 right here. Then I'll move on to my tens place. That addition looks like 30 plus 20, which is 50, and I'll line that up right here. Notice I'm lining everything up in the same columns. And then from here, I'll add my 15 and my 50 to get 65. In this example, a common mistake is avoided. Some students, when they're first learning this algorithm, and in fact, I've seen it in adults at the college level, when they're adding the ones units, they get a double-digit number, they don't know what to do with this extra 1. You're only allowed to write a single digit in each place value, and for some people, they'll try and squeeze both the 1 and the 5 into one place value, and that's not okay. In fact, using the standard algorithm, we have this technique called carrying the 1, and it's technically regrouping. When we do 7 plus 8, we get 15. But 7 plus 8 is only allowed to have a single digit in the ones place. So I can't write 15 right here. That would be incorrect. What I need to do is recognize that 15 is the same thing as 10 plus 5. The 10 I could look at as one group of 10. I carry it over to say I have one more 10 to consider in the tens column, and I only have 5 units left over from 7 plus 8. Once I've finished adding my ones units, I can move on to my tens units. The 1 plus 3 is 4, plus 2 more is 6. There's not a lot of work shown here. It's not quite clear what we mean by having this little tally mark on top of the 3. Maybe it is familiar to you and so you trust and believe it, but when you're explaining this to someone who's never used it before, it can be confusing. Let's look at our addition problem again, 186 plus 127. And I want to show it to you in a couple of different ways. First, using expanded, and then we'll do standard. So if I do this in expanded form, I'm first going to add my ones digits. 6 plus 7 is 13, so I'll write 13 down here. Then I'll move on to my tens, so that would be 80 plus 20, which is equal to 100. Then I'll move down to my hundreds, which is 100 plus 200, 100 plus 100, which is 200. All of my numbers are lining up based on their place value. 3 plus 0 plus 0, that's 3. 1 plus 0 plus 0, that's 1. 1 plus 2, that's 3. Notice that this number, 313, is the same number we got when we represented this using base 10 blocks. We have 3 flats, 1 long, and 3 units. Now, when we did this with the blocks, we had to regroup. And we technically are demonstrating the need for regrouping using this expanded algorithm. 6 plus 7, there is a regroup because we have 13. 80 plus 20, there's a regroup there as well because we have a 1 in the hundreds place. And then 100 plus 100, there's no regrouping there. That sum is still just counting how many hundreds we have. Let's try this problem again, but this time using the standard algorithm. Adding my ones, 6 plus 7 is 13, but I can't write 13 down here. I write the ones digit and carry the tens. Then I add in my tens. I have 1 plus 8 plus 2, which is 11, but I can't write 11 down here. I keep the ones digit from 11 and carry the 10. And then in my last column, I have 1 plus 1 plus 1, which is 3. Now notice there's not a lot written here. It's quick, it's dirty, it's efficient, it's wonderful, but this is not the best way to teach addition. It's something that you do after you've mastered addition. Notice we're still regrouping. We have not avoided the fact that regrouping was required. The ones on top of our sum are still representing the fact that we had to regroup every time we added the digits in our ones place and our tens place. So we're not making the math more simple, we're making the notation simple. Sometimes when you trade simple notation for less simple notation, you actually get the opposite in the amount of mental effort. So using the standard algorithm requires a lot of thought in our minds and very little writing. Using the expanded algorithm requires less thought in your mind because you're writing a lot of it out. It's also great for teachers who are looking at students' work. You can see where they made their mistake. With the standard algorithm, it's really possible to make a lot of mistakes and to not know exactly where the mistakes came from. If I did 6 plus 7 is 13 and I carried my 1 correctly, but maybe I forgot to add that 1. 8 plus 2 would be 10. Carried my 1 correctly. I got 303. But based on what I'm looking at, it's not entirely obvious what concept I misunderstood here. I can see that I got the wrong answer, but why? What did I do wrong? Or if you're looking at a student who's using the standard algorithm and they don't understand regrouping, they might write 13 under 6 plus 7. They might write 10 under 8 plus 2. And they might write 2 under 1 plus 1. Again, we know that this is not the correct answer, but explaining where the thought process was that was incorrect can be difficult when this is all you have to work with. With the expanded form, we can see each step of the way where their thoughts were correct and where they might have been incorrect. And then again, once you've mastered addition, feel free to use the quick and dirty standard algorithm.